For as long as humanity has gazed up at the night sky, the moon has been a constant presence, a silent observer of our evolution and our history. But could this barren, lifeless rock ever be transformed into a place where we could live, breathe, and build a future? Imagine a world where the moon isn't just a satellite, where it becomes a second home to humans, a place where cities rise, crops grow, and families live. It's a bold vision, but it's one that scientists, engineers, and visionaries are beginning to think seriously about. With advancements in space technology, could we one day terraform the moon? Today, the moon is a cold, inhospitable place. It has no atmosphere to speak of, leaving its surface exposed to the harshness of space. Temperatures swing from blistering heat during the day to freezing cold at night, extremes that make it impossible for humans or most forms of life to survive. The moon's gravity is only about 16.5% of Earth's, meaning that anything standing on its surface would weigh far less. While this sounds appealing in some ways, imagine jumping 6 times higher than you can on Earth. It would also create significant challenges for human health and biology. What if we could alter all of this? We know that Earth's atmosphere is a delicate balance of gases held in place by the planet's magnetic field. To terraform the moon, we need to recreate that balance, introducing gases like oxygen and nitrogen, gases that are essential for life as we know it. But unlike Earth, the moon lacks the resources for such a transformation. There are no oceans, no thick clouds of carbon dioxide, no forests to generate oxygen. Without these ingredients, the road to a breathable atmosphere would be long and difficult. But what if we could bring them from elsewhere? Could we pull in gases from asteroids or harvest water from the moon's poles? Currently, the moon is exposed to the unfiltered solar winds, which strip away any thin atmosphere it might develop. Without a magnetic field, any atmosphere we create would likely be blown away over time. To prevent this, we would need to create an artificial magnetic shield, a technological marvel that could protect the moon's newly forming atmosphere from the harshness of space. This is where things start to get complicated. We would need to release huge amounts of gases like carbon dioxide, nitrogen, and oxygen, potentially using technology like greenhouse gas generators to warm the moon's surface. But before we could even think about introducing gases on such a scale, we would need a significant source of water. Water is the foundation of life. It's essential for hydration, for agriculture, and even for producing oxygen through electrolysis. What if we could mine water from the moon's icy poles, or even capture it from comets that pass through the solar system? These sources of water could be extracted and used to create the first step in a truly Earth-like environment. Over time, with the right technologies, we could begin to release more gases to thicken the moon's atmosphere and raise temperatures, potentially even leading to the first signs of a lunar weather system that could mimic Earth's conditions. We've already identified ice deposits in the moon's permanently shadowed craters, regions that remain colder than anywhere on Earth. These ice reserves could provide water for drinking, irrigation, and even the creation of hydrogen and oxygen through electrolysis. But the process of turning the moon into a self-sustaining environment requires more than just water. It requires life. For humans to thrive on the moon, we would need a reliable food supply. Traditional Earth-based farming won't work in the moon's low gravity or extreme temperatures. But what if we could build specialized greenhouses, enclosed, temperature-controlled habitats designed to simulate Earth's climate? Inside these greenhouses, crops could be grown in a controlled, Earth-like atmosphere. The moon's low gravity would be a challenge, but researchers have suggested that plants could be adapted to thrive under lower gravity conditions. Imagine hydroponic farms growing everything from wheat to potatoes, vegetables to fruits, all beneath transparent domes that mimic Earth's sunlight. The idea of farming on the moon would be the cornerstone of creating a truly livable, self-sustaining colony. What if we could one day walk into a lunar farm and see lush greenery, something once thought impossible on a barren rock in the sky? Creating cities on the moon would be a massive engineering feat. The lack of atmosphere means the pressure inside our habitats would need to be carefully regulated. The buildings would need to be airtight, protected from the harsh vacuum of space. The lack of natural resources would make construction a challenge. But what if we could build habitats using lunar materials? The moon's surface is covered in a material called regolith, a layer of fine dust and rock created by billions of years of meteoroid impacts. This regolith could be used to build structures, either by melting it down or 3D printing with it. Imagine structures built entirely from the moon itself, domed cities, underground shelters, and even towers that stretch up into a sky filled with the glow of distant stars. For energy, solar panels could be placed on the moon's surface, providing a constant source of power. The poles, where sunlight is constant, would be ideal for large solar arrays, offering renewable energy to sustain the entire colony. What if the moon became a bustling metropolis with roads, schools, hospitals, and bustling markets, built not with resources from Earth, but from the moon itself? With only 16.5% of Earth's gravity, humans living on the moon would face significant health challenges. Long-term exposure to low gravity could lead to muscle atrophy, bone density loss, and circulatory issues. Our bodies are designed for Earth's gravity. Living on the moon could profoundly affect our physiology. What if we could create artificial gravity? To counteract the effects of low gravity, we could design rotating habitats that generate artificial gravity through centrifugal force. This technology could simulate Earth-like gravity inside the habitats, allowing humans to live more comfortably and healthily. Additionally, low gravity would affect how we grow plants. Without the proper gravitational pull, water would not move in the same way, and roots would struggle to develop. By creating artificial gravity in our greenhouses, we could help crops thrive, mimicking Earth's conditions and supporting a more sustainable, long-term ecosystem. Terraforming the moon isn't just about making it a place to live for a few hundred people. This could be the beginning of humanity's expansion into the stars. The moon could become a stepping stone for further exploration of our solar system. With its proximity to Earth, it could serve as a launch pad for missions to Mars, asteroids, and beyond. A lunar colony could become a training ground for future astronauts, scientists, and engineers, creating a new generation of space explorers. But what if the very process of terraforming the moon changes who we are as a species? In the pursuit of transforming the moon, humanity could redefine its place in the universe, becoming a multi-planetary species capable of altering entire worlds. The ethics of such a transformation would be complex. How far should we go in reshaping the natural world? Should we terraform other planets or leave them untouched? The moon's transformation would force us to confront these questions about our role in the cosmos and the kind of future we want to create for ourselves. It would be one of the most incredible achievements in the history of humankind, an endeavor that would stretch the limits of technology, creativity, and perseverance. Though the challenges are immense, the potential rewards are even greater. A transformed moon could become not just a backup for humanity, but a thriving new world. A world where future generations could live, work, and explore the universe from a new vantage point.